Okay, guys, time to have a crack at part two. Been so busy lately, I just haven't had a chance to do anything. So, everyone's told me this is super hard. I do not know. Haven't looked at it. We've got that equation, a cubic graph. State the coordinates of all axial intercepts of f of x. Well, we know we're going to have one at -1, 0, one at 0, 0, and one at 2, 0. Find the coordinates of stationary points of f of x. Okay, so x minus 2, x plus 1, I think it was. We want to find the maximum, and that is between -1 and 0. So we get 1 minus root 7 on 3. And our y value, 14. What the hell's going on? Minus 14 root 7 minus 20. On 27. We then want to do the same thing, but we want to find the minimum. So change that to in, not z in. And we want that between 0 and 2. So root 7 plus 1, or 1 plus root 7 on 3. And then minus 14 root 7 minus 20 on 27. Okay, x minus 2, find the values which f of x equals g of x. So let's put this here. I should have done this first, but I didn't. Define that as f of x, x minus 2. Define that as g of x. And manipulate the maple. I don't have any reading time, so I don't know what I have to define and what I don't have to define. Okay. So x is equal to -1 minus root 5 on 2. Root 5 on 2 minus a half. Minus 1 on 2. And I think the other one was 2. Yeah. Okay, write down expression to give the area of the regions bounded by f and g. So f of x, g of x. All right. So f of x minus g of x between those 2 points. So area f of x minus g of x dx plus g of x minus f of x dx. The lowest value, -1 minus root 5 on 2, root 5 minus 1 on 2, and this one's going to be root root 5 minus 1 on 2 to 2. That should be right. Hence, find the total area of the regions. Okay, so we want to go integral, lowest value. Now, there's actually a cheap way to do this. We can just go from our lowest value to our highest value of the modulus, because it wants it to decimal places. We can just say f of x minus g of x, and that should be in the mod as well. So anyone who does special will know that when you mod something, it makes everything positive. And we wanted it to what? 2 decimal places. So the area is approximately 5.95 when we round it. Yeah, what I was talking about is if we mod both functions, it makes them both become positive for all values. So it doesn't matter if we do f of x minus g of x or g of x minus f of x. The equations will both be positive. So if I change that to a g and I change that to an f, we'll get exactly the same answer. Okay. This is lagging. Let h of x be that, where h of x is f of x plus k. Find all possible values of a and b. Okay, so here we've got a turning point that's on the axis. And f of x is a translation up or down. So if we were to grab that graph, and then we moved it down, that would be b, and that would be a. Or, if we moved it up, that would be b, and that would be a. So, we know, because this point here, we know what the y value is. If we move it down that amount, we're going to end up with that graph. So we could say x minus a, x minus b squared is equal to f of x minus, now what was that turning point, the y value of that turning point? That's the negative one. So 14 root 7 minus 20 on 27. 14 root 7 minus 20 on 27, or x minus a, x minus b squared is equal to f of x plus, now that's actually going to be negative 14 root 7 minus 20 on 27. Now, let's see if the calculator is smart enough to say f of x f of x, grab that, f of x minus that, can it factorize that? Apparently not. But what we can do is get our x-intercepts. What the hell? Okay, I think it's this that I've stuffed up. So let's go back. Let's minus the whole thing. So if we try to R factor that, that's not going to work either. Let's try solve it. Okay, so when we solve it, we get two x-intercepts. We get this one here, which we know it has to be, because it's that translated down value, it's got to be that value there. And then the other x-intercept is going to be this one. So when we moved it down, we get that our turning point value, which is B, is that. So 2 root 7 plus 1 on 3. 2 root 7 plus 1 on, was it 3? 3. And A is 1 minus root 7 on 3. And with this one, so that value has to be the positive one because it's x minus, and then that value has to be the negative one because that value is to the right, that's the x-intercept. And then if we do it the other way, we effectively want this equation. How the hell is it? That, well, we could just go copy that, paste. Okay, so it's plus, and then I think it was minus that. If we let that equal 0, and then we solve, what have I done? Okay, so f of x minus, no, plus the other y value, is that one. So we've got to move it up this amount. That's how far down it is. Okay. So that one we want to minus that one. If I stuff that up, let's minus, and then our y value of our turning point, that's the positive one. Let that equal 0, and see if we'll stuff that up. Why is it doing that? I think I just did the same thing again. So minus that, and then make that a plus. Okay. So that's when we move it down, because the y value is that. When we want to move it up, we've got to add on whatever the other value was. Now, because it's negative, we can just subtract negative that, and that. Okay, so then that value is negative, so that's the x-intercept, which is the a value. So a is negative 2 root 7 plus 1 on 3, and b is root 7 plus 1 on 3. Okay, that was different. Okay, the following diagram represents an observation wheel with its center at the point P. Passengers. Oh, my phone's going crazy. Sorry, I'm just going to answer a text. Okay. All right, so we've got this. The wheel moves anti-clockwise, so that way. Constant speed completes one full rotation every 30 minutes. When a pod is at the lowest point on the wheel, it's 15 meters above the ground. The wheel has a radius of 60. So we know that's 60, 60, 60. Okay, consider that function negative cos blah, 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 which models the height above the pod originally situated at the point A after time t minutes. Show that B is that. What's B? Okay, full rotation every 30 minutes. So B is equal to 230 is equal to 2 pi on B. So B is 2 pi on 30, which is pi on 15. And C is 75. So C is 15 plus the amplitude, which is 15 plus 60. C, let's say that. C is equal to 75. Find the average height of the pod as it travels from the point A to B. Okay, so we know average height, average value. It's 1/4 of the circle. So if a full circle is 30, 1 on 7.5, from 0 to 7.5 of h of t dt. So what do we have there? 1 on 7.5, the integral from 0 to 7.5, make sure it's in radians, negative, did I say 60? 60 cos pi x on 15 plus 75 dx, 36.80 meters. 36.80 meters, which seems reasonable. 30's about there. Yep. Okay. Find the average rate of change in meters under the height when it travels from the point A to the point B. So the average rate of change is h of 7.5 minus h of 0 over 7.5 minus 0. It's only one mark, so I shouldn't have done that. Okay, let's define that as f of x, all of it. And then we can say f of 7.5 minus f of 0 over 7.5 minus 0, 8. Average in meters per minute. Okay, so 8 meters per minute. So where does it go from 15 to 75? So it goes up 60 meters over 7.5 minutes. Yeah, that sounds right. Okay, after 15 minutes, the wheel stops moving and remains stationary for 5 minutes. This continues to moving at double its previous speed for another 7.5 minutes. The height above the ground of the pod was initially at point A. After 10 minutes can be modeled by the piecewise function W. State the values of K. Okay, so K, 15 minutes is going to go to there and then up to there. So it's going to be at its maximum. So K is 135 minutes. And M, if we double the speed, the time's going to be twice as quick. So M has to equal 2. Final possible values of N. Alright, so we know that at 27.5, this thing is going to get back down to 15. So we know h of 2 times 27.5 plus n has to equal 15. So we should be able to solve this in our calculator. We can say f of 55 plus n equals 15. Solve for n. Okay, 30 constant n minus 55. So minus 55 plus 30 times a constant. Or if you think about it, minus 55 would be the same as 5. Let's have a look. So I'm thinking n is equal to 5 or minus 55 plus 30k. K is an element of z. So if we try that, we could sketch the graph f of x, and then we could sketch f of if k was 0, we'd have 2t plus 5. 2x plus 5. Now, we know it's between, let's say, 0 and 30, because we know it's 27.5. 0 and 135. Okay, so there's that graph. There's the 5. So if we sketch that from 0 to 15, and if we sketch this from, what do we stop for? 20 to 27.5. Okay, and then if we sketch 135 for 15 to 20, okay, now just say we were to change this. If we put 35 into it, we still get the same graph. If we put 65 into it, we still get the same graph. So if we translate it, we're moving it 5 across, and then we know the period's 30, so 30k is going to end up translating that graph 1 period across. So we have infinite solutions in that case. Oh, there we go, sketch it. Alright, so we know it starts at 15. We know it goes to 15 and 135. And we know halfway between that, 7.5, it's going to be at the center, which is 75. Why did they do such a shit scale? It's going to look something like that, and then like that. And then we go for 5 to there. 0, 15. We know it's going to end at 27.5, 15. And then halfway between those, 20, I can't be bothered thinking about this, 27.5 minus 20 divided by 2, 23.75. 23.75. It's going to be at that value there. So it's going to look like that. Oops. It's going down at twice the speed. And like that. Okay, sketch a piece showing the coordinates of the endpoints. So 27.5, 15. That's pretty much all we need to do. We know that's 15, 135, and that's 20, 135, but didn't ask to do that. But yeah, so that's our graph. Now it's finished. Okay. Question 3. The limit as x approaches negative infinity of g of x. So let's get rid of what we got. Was that 2 to the x, 2 to the power of x, plus 5. Let's define it as g of x. Alright, we can do, now it's not very hard, but the limit as x approaches negative infinity of g of x. It's 5, which makes sense, it's just the asymptote. The derivative can be expressed in that form. So d dx of g of x. K is the coefficient, which is natural log of 2. Let A be a real number. Find in terms of the equation of the tangent g at the point A, g of A. So that's nice and easy. 2 interactive calculation line, tan line at the point A. If I don't have A defined as anything. Okay. I'm just going to copy this screen. And paste it. So we get y is, I'm just going to go with the first equation. Oh no. 2 to the a plus, put that at the front, natural log of 2 times 2 to the ax minus 2 to the a times a. Let's say a times 2 to the a. 2 to the a times a plus 5. Hence, otherwise, find the equation that passes through the origin correct to 3 decimal places. Correct to 3 decimal places. So, we know that thing equals 0 given x equals 0. And then we've got to solve that sucker for a. Okay, so then we get the equation of the tangent, either of them. Let's go with this one. And we say given a is that. So 4.25x um, 4.25 where x equals 0, y equals 0, 0, a is equal to 2.6178. Therefore, y is equal to 4.25. Where did it go? 4.255 x. I think that's right. Okay, find the coordinates of the point of inflection for h. 2 to the x minus x squared. So I'm just going to call that f of x. We're probably going to need some of that stuff. 2 to the x minus x squared. Define it as f of x. Okay, go in and sketch it. So f of x inflection 2.058, 2.058, and negative 0.07. I think it wasn't. So what was that negative? Where's negative, 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 negative? Yep. Find the largest interval values of x for it's strictly decreasing. So we want to find the turning points. Max 0.0. This is kind of stupid because it asks for it. To 2 decimal places, so 0.049. And then my min is 3.212. I guess so this fits both of those values, and it includes those values, but it's a stupid question. Because you'd need exact values. I don't like that question. Okay, apply Newton's method with initial estimate of x naught is 0 to approximate the intercept of h. Okay, so we can say x minus f of x over d dx of f of x given x equals 0, negative 1.443, negative 1.443. Why isn't this bloody thing loading? Negative 1. Negative 1.443. I think the app crashed. Okay, now we do the same thing, but we use our previous answer. Negative 8.97. Sorry, negative 0.897. And then we do the same thing again. Negative 0.773. Okay. Explain why that should not be used as an interval estimate. Log E2 times 2 to the x. So that's the derivative. And if that equals 0, the denominator in Newton's method will equal 0. We can't divide by 0, hence there will be no solution. I.e., result in undefined solution. Because it's a turning point. If you've got a turning point and you use Newton's method, it's never going to intercept the x-axis. Okay, there's a positive real number for n, for which n of x has a local minimum on the x-axis. Find this value. So n to the, what was it? N to the x minus x to the n. Let's call that g of x. Okay. If we solve g of x equals 0, or if we solve this for n, I'm like, why didn't that do anything? G of x equals 0. Why does it not work? What's the derivative of that thing? So d dx of that, we know that equals 0. If we solve that, okay, so that equals 0. What have we got? We've got that equation, and we've got g of x equals 0. So the turning point equals 0, and the original function equals 0, and we want to solve for x and n. So local minimum on the x-axis. I wonder if we say, here, given n is greater than 0, is greater than 0, and then do the same with this equation, if it will solve. That's really annoying. Okay, so we know n to the x is equal to x to the n. What was our other equation? Log n of n to the x minus n x to the n minus 1. That also has to equal 0. Okay, we can't even take out anything there. X to the n. But yeah, the other bloody calculator is going to solve this. So, x to the power of n equals, minus n to the power of x. Store that as f of x. Find d dx of f of x. And then we know we want to solve simultaneous equations. So we know f of x. Oh shit, is that simultaneous? Menu, algebra, solve system of equations. Okay, so we know f of x equals 0. And we know d dx of f of x equals 0. And we want to solve for x and n. Have I copied it down now? Log e n to the x log e n to the x minus n x to the n minus 1 log e n times n to the x is equal to that. I could replace that with x to the n. So log e n x to the n from this minus n x to the n minus 1 is 0. We know we could take out x to the n. We'd be left with log e n minus n x to the negative 1, n on x. So we know x to the n equals 0, or log e n minus n over x equals 0. Log e n, so bring that to the other side, n over x. So here, this one we know has x could equal 0. Here, if we switch them, we get x is equal to n over log e n. Find the value of n. Now, if we sub 0 back into that, we're not going to get anything because it says a positive real number. If we sub that into there, n over log e n. So, if we said, did I call it f of x or g of x? G of x equals 0, given x equals n over natural log of n. Solve that for n. That value is e to the 1 as a decimal. Yes, so n is equal to e. That's a pretty tricky question. I don't like how I solved it, but it makes sense. Okay, manufacturer produces tennis balls. The diameter of tennis ball is normally distributed D with a mean of 6.7 standard deviation. That probability D is greater than 6.8. So, normally distributed, lower, 6.8 to infinity. Standard deviation was at 0.1. And that was 6.7, the mean, 0.1586. To put it in places, it was a 0.1587 then. 0.1587, I think. Okay, now the minimum diameter of a tennis ball is larger than 90% of the minimum is larger than 90%. Find the minimum diameter of a tennis ball that is larger than 90% of all tennis balls produced. So, we want the top 10%. Stupid bloody question. So 0.9, 0.1, 6.7, was that the mean, or was it 6.8? 6.7, I think. 6.828. 6.83 centimeters. They're packed in solid cylindrical cans. Tennis ball can fit through the opening at the top of the container if it's smaller than 6. Opening at the top of the container can fit through the opening. So we want to know the probability it's less than 6.95. So negative infinity, 6.95, 0.1, 6.7, 0.9938. Random selection 5, at least 3 tennis balls can fit through the opening of the top of the container. So we could say X is binomially distributed, 4, and the probability they fit through the top of the container is 0.9938. The probability that X is greater than or equal to 3. So we use binom CDF from 3 to 4 out of 4 trials. And let's say that's 0.99. I'm just going to put that because I'm going to grab that value. And then I'm going to replace that with all of that. 0.99977. 0.99977 is 0.9998. Okay, a tennis ball is classed as grade A if its diameter fits between that, otherwise it's classed as B. Given that the tennis ball can fit through the top of the opening at the top. Okay, so it's got to be, this is given that it's less than or equal to 6.95. Okay, so find the tennis ball can fit through the opening at the top of the container. Find the probability it's class A. So it's A, given that it can fit, is it's the probability that it's A and can fit, which is just the probability it's A, over the probability that it can fit. Now we know the probability that it's A is 6.54 to 6.86. 6.54 to 6.86, 0.1, 67. What? 6.7. Did I do 67? 6.7. Okay, 0.8904. Over the probability it's less than 6.95, which we found up here. 0.9938. Okay, if we do that divided by that, 0.8959, 0.8960. Okay, the manufacturer would like to improve the processes to ensure that 99% of tennis balls are class A. Assuming that the mean diameter of a tennis ball remains the same, find the standard deviation. So, what's classed as grade A? Alright, so we know probability that, what's the values? 6.54 is less than or equal to x, which is less than or equal to 6.86, is equal to 99%. So we can chuck this in our calculator and go from 6.54 6.54, was it 6.86? Standard deviation we don't know. Our mean is 6.7. Now that's exactly halfway between those two. So we could use symmetry, but if I let that equal 0.99 and I solve for x, we get 0.0621. .0621, so it's 0.06. Oh shit, this question's going to go on forever. Okay. An inspector takes a random sample of 32 tennis balls and determines the confidence interval of the population to be that. Find the level of confidence the population is within the interval as a percentage correct to the nearest integer. So we know p hat 0.7382. And then the other one's 0.9493. Divide that by 2, put a 5 on the end. 0.84375. Okay, find the level of confidence that the population proportion of A-grade bulls is within the interval. Okay, can we get that? 27 on 32. All right. So what are we trying to find? 32 times. Determines confidence A-grade bulls to be that. The confidence interval is that. Find the level of confidence that the proportion of A-grade bulls is within the interval as a percentage. So we know the error is the top value, 0.9493 minus that value. So 2111 on 20,000. So we know 2111 on 20,000 is equal to our Z value times our standard deviation, which is 27 on 32, times 5 on 32, divided by 32, the size in the population. So let's solve that. That divided by the square root of 27 on 32 times 5 on 32 divided by 32. 1.64444. Okay, so we know Z is equal to 1.6444. So if we said if we went from negative 1.6444 to 1.6444, we get 90%. 90% confidence interval. Okay. A telephone used by and the serving speed in meters per second of A grade turns a continuous random variable that. Find the probability serving speed exceeds 50 meters per second. Okay. What's this bloody function? 1 over 6 pi. Was it sine? Sine. Square root. Look like a fraction. V minus 30 on 3. X minus 30 on 3. Let's define it as f of x. Okay, so 50 meters per second. So we want to go from 50 to 3 pi plus 30. 50. What did I say? 3 pi, was it squared? Plus 30. Yep. Dx. Point 1345. Find the exact mean serving speed, grade A balls in meters per second. So our lower value was 30, was it? 30. And then here we've got to do x times that. 3 pi squared plus 12. Meters per second. The serving speed, we nearly finished this one, of grade B balls given by the continuous random variable W with the probability density function G of W, a transformation that maps F to the graph of G, where G of W is A times F of W on B. If the mean serving speed for a grade B ball is 2 pi squared plus 8 meters per second, find the values of A and B. Okay. So A is going to dilate the function from the it's going to dilate the function from the x-axis, and B is going to dilate the function from the y-axis. So we've got to find a value that when we multiply that by A and then times it by that, it's going to give us that. So A times let me think. So if I said 3 pi squared plus 12 times some variable n is equal to 2 pi squared plus 8, we know that's 2/3 of that, and that's 2/3 of that. So if we multiply that by 2/3, we would be dilating it 2 from the x-axis, g of w is, okay, so we don't want it to change. We know it's just f of that value. So if a was 3 on 2 from the x-axis and b was 2 on 3 from the y-axis, they would effectively cancel each other out. We could test it. So we could say, what did it say the mean was? The mean serving speed. Did I define that function? I did. So here, if I said that, now from the y-axis, if b is 2/3, then that's going to be 3 on 2. And then that is going to be, hang on, that one's hurting my head. F onto the graph of g, where g of w okay, g of w is a. So if we dilate this by some factor, we end up with g of w, and g of w gives us that. The only thing is it's going to modify our so to get from that to that, if we multiply it by 2/3, if you multiply that by 2/3, you get that. So if we were to multiply that by 2/3, if we wanted to dilate 2/3 from the x-axis and 2/3 from the y-axis, g of w hang on, it's the other way around. To get from that to that, we're going to multiply it by 3 on 2. So 3 on 2 from the x-axis, a would be 3 on 2. And if we wanted to go 3 on 2 from the y-axis, b would be 2 on 3. Or would it be 3 on 2? I think it's 2 on 3. Not 100% sure about that one. Okay, I'm just going to move on. Let f of x equal that, and g of x be a transformation of that. A dilation of a half from the x-axis, so that's that. We could say reflected in the y-axis to get that, and then translated 2 units in the positive x direction. Okay, the functions g1 and g2 are created both of the same rule as g but with distinct domains, such that g1 is strictly increasing and g2 is strictly decreasing. Okay, so e to the x plus e to the negative x, define it as g of x, and then, no, call that f of x, so that's what it does in. And then f of a half of f of 2 minus x, define that as g of x. Okay, g1 and g2 are created both of the same rule as g, but with distinct domains. That is, g is strictly increasing. So let's sketch f of x, and then g of x. Okay, so the turning point is 2, 1. So we know g1 is when it's strictly increasing. So g1 of x has a domain of 2 to infinity and a range. Y is 1 to infinity. So g inverse of g1 of x has a domain of 1 to infinity and a range of 2 to infinity. Thank God we're nearly getting there. Okay, the graph by g versus g, the inverse of g1 and g2 and the one y equals x. The intersection of the points are labelled under P. Find the coordinates of P and Q. That shouldn't be too hard, should it? G of x equals x. Um, 1.27 and 4.09. They have to be the same x and y value because it's on the line y equals x. Find the area of the region bounded by the graphs of G, the inverses of G. Find the area region bounded by the graphs of G, which is so it's just the area there. Okay. So the area is 2 times from 1.27 to 4.09 of x minus f of x, or g of x, hang on, x minus g of x dx, because g of x is that translated function. So the integral from there, so far this question looks a lot worse than what it actually is. X minus g of x dx. Whoa. 2.78, and then we're going to times it by 2, 5.56. Okay. The turning point of h always lies on the graph of the function 2x to the n, where n is an integer. Find the value of n. 1 on k, 1 on k, is what it was. 1 on k minus x times k minus x. Alright, so the turning point is at -1. That turning point (2x to the n). Okay. The turning point of h always lies on the graph 2x to the n, where n is an integer. Okay, so we can only use integer values. The turning point of h of x is 1 on k, f of k minus x, and k is positive. Okay, so there, find the value of n. What? Oh, k and n are not the same values. Okay, so if I said that was 2, the turning point of h always lies on the graph of 2x to the n, where n is an integer. So if we make it a 3, make it a 4, I'm not even sure I get this question. The turning point of h, so that translated graph of f, lies on the graph of the function 2x to the n, where n is an integer. Find the value of n. so it only lies on it if I change the value of k. You can see it only lies on it when n is -1. I don't know how they expect you to find that out, but I just did it through trial and error. Okay. Okay. So the rule for the inverse function is that find the smallest value of k to find the value of k that will intersect. Let h1 be k to infinity. h1 is equal to h of x. I can't even fucking remember what h of x is. Okay, so that's that. Let h1 be from k to infinity. h1 is equal to hx. Find the rule. The rule for the inverse is that. Okay, so log e, k on 2x, log e, k on 2x plus a half, square root, k squared x squared minus 4. K squared x squared minus 4. Is that it? Plus k. Okay, so now we'll go back to small values. Now, k to infinity, so they're going to be intersecting the inverse of h1. So hang on. The inverse of h1 is that. H will intersect. Oh, k has to be positive, doesn't it? Okay. So what's the smallest value? So if we keep making this smaller and smaller and smaller, you could solve this on your so let's see if they intersect. Let's try another smaller value. They don't intersect. So k is equal to 1.27. You could let the derivatives equal 1 and also let the equations be equal and then solve to see what value that gives. But I don't even know if the calculator would solve that. Is it possible for the graph h1 to intersect twice? It is possible. Find the area of the region bounded by the graphs of h of x when k is equal to 5. Okay, so which one is our lower graph? Okay, so if I said, get rid of this stupid thing. If I said given k equals 5, we end up with, sketch it, freaking 5, 5. Okay. So firstly, we've got to say that equals x and solve. Not for k. I want to solve for x. Okay. Why did I delete that other freaking graph? Let's go back and what was the other graph? It was log e. It's going to be 5x on 2, and then plus 1/2 of square root 25x squared minus 4, and then plus 5. Okay. If I were to intersect twice, this occurs when k equals 5. So find the intersection points. 1.4509 to the highest value, 8.7816. And then the higher graph is h1 inverse of x minus h of x dx. Now, if we go integral between the intersection, that point and that point, we get 43.91 meters squared. To 2 decimal places. Okay. Yeah, that was a pretty hard exam. I have no idea how long it took me, but if you got through it and got a reasonable score, well done. There's a couple of things in that are they're pretty hard to explain, especially this A and B thing. Where'd it go? This thing here. Just trying to think if there's an easier way to work it out. They're both 3 on 2. I'm pretty sure that's right. So what was our... We could use integration and find that, but I can't be bothered right now. Hopefully it's correct. I'm pretty sure it is, but yeah. All right, thanks guys. I'll hope you did okay. Bye.